Everyone, so this talk will be extremely useful for those who are actually building a blockchain that are lack of ecosystems, right? Because I'm going to show some magic that can give this blockchain lots of ecosystem just in one push button. Today I'm going to introduce something that's called turn a Web2 browser application into a Web3 application through a magic WebAssembly CK virtual machine. That means you can go down the street, grab someone that can only write HTML or JavaScript or Rust, and plug in their application into your ecosystem via build a browser application and then generate browser WebAssembly CK proofs and verify the CK proofs on your own blockchain so that you can turn arbitrary small applications into one of your ecosystems. And how does that work? I'm going to show you something that I still have to sign up. So yeah, so I'm going to start with a demo. The demo is a super dumb small game that's building in WebAssembly, right? Because WebAssembly can be natively supported in browser, right? That is a huge advantage. So once you grab some guys that can write a small browser game like this using WebAssembly, people can easily interact, play a card game, right? Attack, strike, and next round, and maybe here make some mistake and game over, and that's the gameplay, right? So if you actually would like to actually install this gameplay into your ecosystem, you have to sign every time you are going to interact with your chain, right? But in your WebAssembly CK virtual machine, do not have to do that. You allow the user to do the gameplay, and in the end, you create a proof that will actually run the gameplay, generate trace in a CK WebAssembly virtual machine. And this virtual machine cloud somehow will generate a proof of your gameplay. And then you use this gameplay proof on chain, verify that. So it's actually generated proof. And let's see an old proof. So now, oh, sorry, we have some internet latency. OK, so now you can use the generated proof and verify that on your own blockchain, right? Once they actually pass the verification, you give them some kind of redeem of benefits, rewards, NFTs, token transfers. And that's done, right? So what you need to do is that you grab random applications, you compile them into WebAssembly, and then you load them. You load the game in the browser, and then play with it, right? Simple push button, end to end, just leverage some kind of CK WebAssembly virtual machine and leverage the proof service cloud, right? That's done. And you can maybe make 100 of applications in 3 months, right? All you need is some Web2 developers, and it brings huge amount of applications for your ecosystem. Once you get ecosystem, you get everything, right? Okay, thanks. That's my talk. Okay.
Wow.
Have a good day.
Wow. Any questions?
Yeah, any questions? Ah, okay. Okay.
How does the ZKWASM VM work?
Wow, that could be even longer than my talk. It's a Snark virtual machine that is has 148 instructions. So compared to some kind of a famous virtual machine with RISC-0, which has about 38 instructions, we have 148 RISC instructions. And I always make that as an excuse of why the CK WebAssembly virtual machine is slow, twice as slow as RISC-0, because we have 64 bits instructions and 148 different instructions. And it works like you're writing an interpreter of WebAssembly in Halo 2 circuits. It's no longer Halo 2 for us, but I think most of CK guys familiar with Halo 2, so it's a Halo 2-like system. We code in the architecture of the WebAssembly interpreter into the Halo 2 and make a circuit, and that's it. Run the provers in the GPU. But you do not need to worry about that, right? You're using the cloud, right? And we are actually not running the cloud. We actually bypass the cloud running to some of our partners like fan group like Snarkify, right? So I'm not doing all the work, but yeah. So there's already lots of guys in the ecosystem doing the dirty job for you, and you can just code in your ecosystem applications. I mean, lots, right? You have a blockchain. You might worry about your ecosystem every night, right? After that, now you have this ecosystem. You can install lots of ecosystem applications directly into your ecosystem by maybe have a Web2 application portal, right? And utilizing the technology. So it will be great for your ecosystem. Trust me. Thanks. Okay. Have a good day.
I have one question too.
Okay.
In terms of the compilation down through the custom set, are there any kind of like higher level language that allows WASM to be used, or there's
so we only have customs using Rust and JavaScript, because JavaScript now have a J runtime, so which only has about 500,000 instructions to bootstrap. But if you want to do some serious coding, Rust and C is better because it has minimized the trace. But just be careful, do not call anything like serializing JSON, deserializing JSON. It actually kills the virtual machine because it generates lots of trace. So using RLP, using fixed layout, so make it easy, because it's for ecosystems that need dumb applications, right? So don't make that too complicated. Make card games, programmable NFTs, SLG gamings, cardboard games. So yeah. But if you want to build some very serious ecosystem for your application for your ecosystem, you probably need some very good features like continuation, but that way you will need GPUs, localized proving services. You might need Snarkify to actually generate proof for you. So my simple answer is that just keep it simple, and you get lots of applications on board.
Got it. So it's not like any compilation, it's more of a performance issue? But
it needs, compared to RISC-0, which only has 12 seconds for 1 million instructions. We need 30 seconds for 1 million instructions. But for card game, right, when you're actually doing the proof, you can play a Google advertising video for your customers, so that once they actually click the video, skip the video, you have already generated your proof. Right, so keep your players busy. And once they have finished the gameplay, you generate proof for them. So it should be fine.
Like RISC doesn't have like standard library support, but something like that.
Maybe. I mean, yeah. It's sort of. We can have a try. So it will be really dumb to actually you install our browser sandbox. So you cannot use RISC-V in browser, right? So you have to use WebAssembly. That's the trade-off. Yeah. So yeah, okay, we're good. Right. Okay, have a good day.